So we are going to perform an experiment determination of Laplace transform and inverse Laplace transform using Matlab. So we have taken these 5 examples for Laplace transform and these 5 examples for inverse Laplace transform. Okay, so we are taking one by one. So in first example, y equal to e to the power 80. So here variable is a into t. So we have to define the variable a and t in Matlab. So we have to define this variable s, y, m, s, a. We have to put semicolon after defining the variable s, y, m, s, t semicolon. Now we have to write the function y equal to exp. It stands for exponential a into t. Bracket close. You have to put semicolon. Now Laplace of function y. So it will be 1 divided by s minus a. So we are moving to next. So y equal to sine omega t. So our next example is y equal to sine omega t. So here the variable is omega and t. So we have to define omega and t in Matlab screen. So first define s, y, m, s, omega, semicolon, s, y, m, s, t, semicolon, the variable y equal to sine of omega that is w into t. So here omega will be written by w. So we have to put semicolon and we have to take the Laplace. So Laplace of function y. So as we know that the Laplace transform of sine omega t is omega divided by s square plus omega square. So our answer is omega divided by s square plus omega square. So we are moving to next example. So our next example is y equal to cos omega t. So similarly we here also we have the variable omega and t. So define the variable omega and t. So s, y, m, s, omega, semicolon, s, y, m, s, t, semicolon, y, the variable y equal to cos omega into t. Okay, so if we won't put the semicolon, so the result will be shown. Okay, so we have to put the semicolon. So I have shown that what will be the thing when we will put the semicolon and what will be the what will be the result when we will not put the semicolon. So we have to put the semicolon omega into t, put the semicolon. Why? So we are not expecting the result here. So when you are expecting, we are not expecting the result, we have to put the semicolon. Okay. So now Laplace of function y. So it is s divided by s square plus omega square. So we are moving to next example. What is y equal to e to the power minus 80 into sine omega t. Okay, so here the variable is a, the variable is t and omega. and t is already defined. If we will define here t, so here the variable is a, t and omega. So define the variable as a, omega and t. So syms a, syms omega, syms t, semicolon, and variable y equal to ex, the exponential of minus a into t, semicolon closed, bracket closed, put multiply and sine omega into t. So we have to put the semicolon as we are not expecting the result. So put the semicolon. Now Laplace of function y. So our result is omega divided by s plus a whole square plus omega square. So we know that when the function exponential is multiplied with the sign, so it will be replaced by s will be replaced by s plus a when it is minus, and when it is plus it will be replaced by s minus a. Now we are moving to next problem, that is the last one, y equal to e to the power minus at into cos omega t. So in the same manner define the variable syms a, syms omega, syms t. Now the variable y equal to exponential of minus a into t multiplied with cos omega into t. So here I am not putting the semicolon to show that what is the value of function y. So the function is y exponential of minus a into t and cos omega t. So Laplace of plus function y. So we are expecting the result here, so we should not put the semicolon. So it is s plus a divided by s plus a whole square plus omega square. So these are the things, or these are the examples how we will perform the Laplace transform of the function. Now we are moving to the inverse Laplace. Okay, so our first function is y equal to 1 divided by s minus a. So here our variable is s and a. So we have to define s and a. So syms a semicolon syms s semicolon. Now I can copy this. So here we are taking the inverse Laplace of the same function that was the result of the Laplace. Okay, so it will be verified that it is working or not. Okay, so here we are taking the result of the Laplace. So the result of the inverse Laplace will be this function. Okay, so we are just checking it is coming right or not. Okay, so we have taken this function. Now for inverse Laplace I should write I L A P L A C Laplace of function y. So we should not put semicolon here. So here it is coming exponential of a into t. So this was the function. So it get verified. In the same manner, we will verify the result of the Laplace. Okay. So in the next case, we will take this example. Okay. So here the our variable is omega and s. So first define omega and s. So s y m s omega s y m s a omega and s. So here the variable is omega and s. So we have to define omega and s. So what was the function y equal to control C. So this was the function. So we have not put the semicolon. So it is showing the result. So when we are not expecting the result, so we should put the semicolon. Now I Laplace of function y. So the result is sin omega t. So that's fine. The result is sin omega t. So it is verified. Now we are taking the third example. So y equal to s divided by s square plus omega square. So in the same manner, here the variable is s and omega. So first define the variable s and omega, the Matlab command prompt. S omega s y m s a. So we have taken the variable. So we should put the semicolon. Inverse Laplace of y. So put the semicolon here. Okay, as we are expecting the result. So it is cos omega t. So you can see that when the variable when we have taken cos omega t, our answer was s divided by s square plus omega square. So when for inverse, if we take the answer, this should be coming. So it is coming. So the result get verified. Now we are taking the another example. This y equal to omega divided by s plus a whole square plus omega square. So here the variable is omega, s and a. So we have to define s, a and omega. E omega VMS. Yes. So we have to give the one space bar here. So so the function put semicolon I means inverse Laplace Laplace of function y. So our answer is exponential of minus a into t into sine omega t. Now we are moving to the last example. So our last example is y equal to s plus a divided by s plus a whole square plus omega square. So here variable is s, a and omega. So define the variable s, a and omega. So variable can be interchanged. So we can write any of the variable in first, second and third. It hardly matters. Okay. So now define the function y equal to, so we have to put the semicolon I inverse Laplace. So what was the problem? We have not written y. So that's why it is showing error. So I Laplace of y. So we should also put in bracket. If we will not put in bracket, what will happen? So it will show the error. So we should put y in bracket. So our answer is exponential of minus a into t into sine of omega t.